Hello guys, this is CodeNCode and this is sixth lecture of Java Design Pattern series. In this lecture, we are going to get started with the structural pattern. As of now, we have covered all of the creational design patterns, right? So now we are going to get started with the structural design pattern. And the first one we are going to cover is adapter pattern. So in this lecture, we are going to see what is adapter pattern, why you should use it, and why is it beneficial, right? And also along with the implementation of it, right? So yeah, let's get started. So the adapter design pattern. So first thing is this is an structural pattern. The adapter pattern is a structural design pattern that allows objects with incompatible interfaces to collaborate together. Okay, this is very important. Objects with incompatible interfaces, right? I'll explain that with an example, right? And how does it work? It basically creates an adapter class that acts as a bridge between the incompatible classes or objects, whatever you like to call them. And also one of the most important example and one of the most famous example is recycler_view.adapter. This is from the Android library. So if you want to create a list in your app, like contact list, right? There is a list of views you see, right? There you can use recycler view and it requires an adapter. Why? Most of the time when you have the data, let's say contact list, for contact list you have name, contact number, XYZ, things like that, right? But that is stored as either inside SQLite database, right? Or you are fetching it from somewhere. So it is in form of an object, right? You want to convert those into views, right? Object into views. Incompatible, you create an adapter. Adapter takes input, the details or data, and converts them into views, and recycle view presents them, right? So this is one of the most famous example of recycle adapter pattern, right? So let's understand the adapter pattern with a real world example. Here it is. So let's say you have a laptop, right, which only has USB-C port. Now you also have a, a memory card or SD card, right? So now you want to transfer some data from SD card to the laptop, but that is not possible because it doesn't have a port for SD card, right? It only has USB-C port. What you can do in this situation? What you do is bring in an adapter, right? Which is a SD card to USB-C adapter. You plug in your SD card here in the adapter and plug in the adapter back into the laptop, and now you'll be able to transfer data, right? So this adapter is what makes these two, which are incompatible originally, work together. Yeah, this is exactly your adapter pattern. So the one that needs it, the object of another class or the data, is called the client. So in our case, the laptop is the client, and of course this is the adapter, right? And this, the incompatible type or the incompatible data, is called the adaptee. So when you create an adapter, when you create an adapter, you encapsulate the adaptee chair inside the adapter, right? And this interface which plugs in to the client, right? So client will have a specific interface which it expects, like USB-C port, right? So the adapter must implement that interface. It will provide that interface so that it can connect to the client, right? So this is how the you can understand adapter pattern using a real world example, right? So I'll explain implementation also, then it will be much more clear how you basically implement adapter pattern, right? There's one more example you can take, just a second. Let's understand it this way, right? So when to use it, when your application has incompatible types, we just discussed that, or when you are going to implement a third party library which doesn't match your system's interface. So example can be, let's say you have created an application, right, which takes in XML data and present it to the user, right? But now you want to implement, you want to add another library for certain purpose, let's say for monitoring purpose, right? But that library expects data in JSON format. Remember, your application has data in XML format. You want to add a new library, but that library expects data in JSON format, incompatible type, right? So what you'll do, you'll create an XML to JSON adapter, right? That will take in the XML data and then convert it into JSON, right? So the library can use it, right? So this is another example, and the legacy component. So when running legacy component in the new system, So when you are, let's say, your application, you are updating it, right? Earlier you were using certain other thing, let's say other database. Now you have your requirement has changed, and now you are working with another database. Let's say you are earlier working with SQL database. Now you want to work with no SQL database. So you have updated your system to work that way with no SQL database. But now earlier component were working with SQL database. You still don't want to lose, you know, the support of the legacy systems, legacy components. So what you will do, you will create an adapter from SQL to NoSQL and provide a support for the legacy component also, right? So these are the three very famous cases, very important cases where adapter pattern is used, right? So let's understand the implementation of adapter pattern using an example. So let's say we have built an application that logs certain messages onto the black and white screen, that is the console, right? So this is my client, and it expects a logger interface. It works with the logger interface. Okay. My client works with the logger interface. Logger interface has one method, that is log. It takes a message and logs it onto the console, right? And this is the my bad. This is the implementation of that logger interface, right? So if I want to print any message, let's say logger logger is equals to new console logger, all right, and I can do logger dot log, let's say hello world, all right. So if I run this, my system will print the message on the console. Here it is, right? So we have built a system where our client expects a logger interface so that it can log the messages. That is the requirement. Our client depends on logger interface. Now the requirement changes. Instead of printing it on the console, I want to print into the text file so that even when the application is closed, I can actually go back and look into the text file and see the logs. All right. So for that, I have a file logger, which what it does, it opens a logs.txt file, which is here, logs.txt file. I have run it once, that's why there is a log message here. So I have file logger class, which opens a logs.txt file in the append mode, right? And logs the message there with a backslash n for the next line, right? So I want to now log messages onto a text file. How can I do that? Remember, my client, which is main.txt, oh sorry, main.java, main class, it depends on the logger interface, right? Which is incompatible of file logger. I can't just create logger is equals to new file logger, new file logger. It will result in an error. Incompatible types, these are. So how can I make sure sorry, that my client still depends on logger, right? Logger interface, and it can still work with the file logger, because file logger is the one which logs into a text file. So you see, we have incompatible types. So what I can do, I can define a file logger adapter, right? My client expects a logger, right? A logger interface. So I'll define a file logger adapter and make sure it implements file logger, my bad, logger interface, which is the interface that my client expects. Now, since I have defined file logger and it implements logger, I can actually do this new uh, file logger adapter. I can do this. It won't result into an error because file logger implements logger interface that my client expects. That's why we won't get any error and this will work just fine, right? So first thing, so create an adapter, make it implement the interface which your client expects. Step one. Step two, as we also saw in the example here, right? The adapter actually encapsulates adaptee. So what you will do, you will create an object of adaptee, right? So I have file logger here. Using the constructor, you can initialize it. Once you have these two, what main class will do, it will still have an object of that, right? And it will still call the log method. But this time, when the main method the client calls the log method, right? It should not print on the console. It should print on the text file. That is exactly why we have file logger in the adapter. When this method is called, right, we are going to print it on the text file. For that, we have the file logger. So we'll just call the file logger dot write to file method. As simple as that. So client still calls the log method. It still expects the logger interface. We haven't changed that, but we have defined an adapter. Adapter expects a file logger in its constructor. So new file logger. Okay. You see, the client still works with the logger interface and still calls the log method, right? Nothing has changed there, but we are still able to use the file logger class to log on the file. So we have made two classes which are incompatible together. We made them compatible using the adapter. So if I run it now, you see here, log files are completely empty. If I run it now, message won't be printed on the console. You see, it is completely empty. If you go to the text file, it is, right? So let's say hello world again. If I run it again, right, it will log here. See? So this way we didn't change the client. It is still depends on the logger interface. And we made a file logger which was incompatible with the logger interface using a file logger adapter. We made them work together, right? We made them compatible. So this is how you implement this is how you implement adapter pattern. So the way to do is this: define the adapter, make it implement the interface which your client expects. Step one. Step two, have a field of the other class which is incompatible, right? Basically the adaptee, and you can initialize it using the constructor. Since you have implemented the interface that client expect, you will override the methods also. Now when you have overridden, inside it you will use the adaptee and make it work with the client. As simple as that. All right, so this is how you implement the adapter pattern. So I'll provide the code. I'll upload the code on GitHub and provide the link in the description of this video. Right. So yeah, this is it for this lecture. Thank you guys for watching. Until the next video drops, keep coding. Thank you.